time thinking about inverse trig properties and using that to find exact values. Now, on our little chart right here, we know that in order for a sine function to have an inverse, we've got to restrict the domain between -1 and 1. And where is the sine going to be between -1 and 1? Well, it's going to be between -pi/2 to pi/2, or the right half of that unit circle. And we see that evidenced right here by the domain of the inverse sine function. Now, what about the cosine? We got to restrict the domain of the cosine between -1 and 1. But for its inverse, that means that that's going to occur between 0 and pi on the unit circle, the top half of the unit circle. Now, for a tangent function, we'd have to, our domain actually would be from -infinity to infinity, but the domain of the inverse function also has to be on that right half of the unit circle from -pi/2 to pi/2. So provided that those are the intervals that we're looking at, and since they're inverses, if you remember, if I were to do in just algebra, and let's say in just algebra, if I were to take f of g of x, and if that equaled x, and if g of f of x, two functions, and that equaled x, then that would verify that those two functions are in fact inverses of each other. In other words, if they're inverses, and we use compositions of those functions, well, they're just going to equal x. So let's first think about this tangent. So I got the tangent of the inverse tangent of pi/3. And the first thing I want to think about is pi/3, this is a tangent function, and so its inverse has got to be restricted to the right half of that circle between -pi/2 and pi/2. And is pi/3 in that right half? Well, yes, it's up there in that first quadrant, pi/3, between 0 and pi/2. So, what is the tangent of the inverse tangent at pi/3? Huh, pretty easy, it's just pi/3. Now, how about the inverse cosine of the cosine at 3pi/2? Okay, 3pi/2. Well, 3pi/2 is in that bottom half, isn't it? Well, just looking at that by itself, when the cosine is at, well, that should be 3pi/4, excuse me. I need to change that. That's actually 3pi/4. So what is the cosine at 3pi/4? Well, let's see, the cosine at 3pi/4, that's going to be in the second quadrant, so it'd be -√2/2. And so then, but that's in the top half of that circle. So the inverse cosine of the cosine at 3pi/2 is also just going to be 3pi/2. In other words, that angle measure. Okay, the arc sine, or the inverse sine, when the sine is at 2pi/3. All right, well, what's the sine at 2pi/3? Well, 2pi/3 is greater than pi/2, so it's going to be in the second quadrant. Of course, we know our inverses have got to be restricted to that first quadrant, but what is the sine at 2pi/3? It is at, it's at the square root of 3/2, isn't it? All right, now let's take this in terms of where the domain is restricted on the right half. Where is the, what would be the inverse sine the angle measure in radian when the sine is 3 pi over 2. Well, it'd be at pi over 3. See, it's got to be in that first half of the function. Can't be at 2 pi over 3 because our domain is restricted to that first half of the circle, or between negative pi over 2 and pi over 2. Got to think sometimes. Thinking's good.